In this video, we're going to be talking about reflections and stretches and shrinks in quadratic functions. So first, there are two different types of reflections that we can see. First, we can see a reflection in the x-axis. And what that looks like is we're taking the negative of our function. So for that parent function, that's going to look like negative x squared. In other words, it's going to flip over the x-axis. So we see here in blue or in black is our parent function. In blue is the reflection in the x-axis. It flipped over the x-axis. A reflection in the y-axis of the parent function is when we make the input negative. And so we get negative x quantity squared. And since the negative is inside of that square, that's really the same thing as negative x times negative x, which gives you that positive x squared. And so we see that y equals x squared is its own reflection in the y-axis. When I reflect that across the y-axis, I just get my parent function back. Then we have stretches and shrinks. So first we have horizontal stretches and shrinks. And a horizontal stretch or shrink of the parent function f of x equals x squared is when we multiply our a in our input. And so f of ax is equal to the quantity of ax squared. And so this is going to be a horizontal stretch when a is between 0 and 1. And it's going to be a shrink when a is greater than 1. And so here, for this horizontal stretch, we're going away from the x-axis. Or y-axis, sorry. So here in blue, we see that is a stretch because we are going further away from the y-axis, while in red we are going towards the y-axis, and that would be a horizontal shrink. And then we have a horizontal stretch or shrink, that should say a vertical stretch or shrink of the parent function f of x equals x squared is when you multiply the function itself with your factor. So it'll be ax squared. And so it's going to be a vertical stretch when a is greater than 1 and a vertical shrink when a is between 0 and 1. And so here the stretch is going away from the x-axis. While the shrink is going towards the x-axis. So we see this red is a stretch. The blue is a shrink. So let's go ahead and go through a couple of examples of identifying these. So we're going to describe the transformation of f of x equals x squared represented by g. The first one I have g of x is equal to negative 1/2 x squared. And so I see this is actually in the form of g of x is equal to negative ax squared, where here I see that my a is equal to 1/2. And then I also see that I have a negative in front, so it indicates to me a reflection. And so putting that together, I see that the graph of g is a reflection in the x-axis, since I have that negative out in front. And since I had multiplied my function by 1/2, this is going to be a vertical shrink. By a factor of 1/2. And again, that is because you're multiplying your function by your a, just like what we see up here under vertical stretch. Okay, number 2, I see I have g of x is equal to 2x quantity squared plus 1. And so I see that this is really in the form of g of x is equal to ax quantity squared plus k. So I see that I am doing a horizontal stretch or shrink this time because I am having a being multiplied into my input But if you remember from the last unit when we were talking about linear and absolute value horizontal stretches and shrinks, your A value is actually going to be the reciprocal of whatever you see here. And I can make a note of that here. And so since I see a 2 right here, this means that A is equal to 1/2. Or what you're stretching or shrinking by is 1/2. And then with that +1, I see that's my K value. So putting into words what's happening, we see that the function G is a horizontal shrink by a factor of 1/2. And I see since I have a +1 at the end, that means that I'm being translated up. So I'm saying translated 1 unit up. Okay, let's look at one last one. Here I have g of x is equal to negative x plus 3 squared plus 2. So at first I notice that negative out in front, so that indicates to me a reflection. And then I have this x plus 3 squared plus 2. I know this x plus 3 is going to tell me something about my h. But I want to go ahead and rewrite this as x minus negative 3. So I know my h is negative 3 and my k is 2. So putting into words my transformation here, I see that the graph G is reflected in the x-axis. Since I have a negative 3h, it's going left, translated left 3. And since I have a positive k, it's going 2 units up.